folks, I'm Simon. Thanks for having me. I'm going to talk about underhanded debugging tactics you can use the next time you need to tackle a bug in production. So real quick, here's some background on me. I'm a software engineer at Attune based out of New York City. By using data, design, and technology, Attune makes insurance as easy as it should be. P.S. We're hiring, come talk to me after if you're interested. I'm also a part-time instructor at General Assembly in New York. I've taught evening courses in front-end web development, JavaScript, and Python, as well as many short workshops. Sweet. So let's talk about debugging. At some point in your career as a software engineer, you're going to encounter a bug that's only reproducible in production, which means it's time to actually debug in production. Honestly, it's one of the most stressful moments as an engineer when you encounter a bug in a production environment that can't be reproduced locally. That's probably how most of us would feel. In fact, it's probably even worse in whiteboarding interviews, which says a lot. My favorite time debugging in production is when, at a previous company, we were trying to launch an important feature by Black Friday. A vendor we were using couldn't provide a testing or staging environment, only a production one. So we couldn't even test the flow end to end without deploying to production. When any issues came up, it was impossible to debug them locally. It was quite a wild journey. We eventually launched the feature and all that stuff. We made a lot of money, but it was very stressful. So real quick, let's review the different deployment environments we might typically have. Engineers typically develop against a local environment where you can edit your application code directly, put in breakpoints, use a debugger, all that good stuff. After developing a feature locally, the code is usually promoted to a QA and then staging environment. We can't edit the code directly in these environments. Just like with production, this makes it tricky when bugs appear in these environments. For example, it's pretty rough when a QA analyst finds a bug on a QA environment where you're unable to reproduce it locally. Great, so let's go through some tactics you folks can use the next time you need to debug your application in production. Or honestly, any place that's not your local environment. I learned these tactics the hard way, so you folks will benefit from my frustration, lost hair, stress, and all that. The first tactic is to not panic. I know it sounds silly, and if being blissful is too much to ask for, just try to be mellow. It's hard enough debugging complex applications, so remaining calm is essential. All right, so let's review the overarching philosophy behind the underhanded debugging tactics that we're going to see. When developing applications locally, as we usually do, we can edit our code and step through it using a debugger when we encounter a bug. If we think about it, our debuggers give us input and output information. So when debugging against production, we need to find a different source for input and output introspection. What this really means is that we'll need to play detective. It usually helps if we ask ourselves questions like, how do I know what code has been executed with what data? Can I do anything to get more introspection into the system itself? If we don't know what's been executed, can I make a hypothesis and test that hypothesis? What are the boundaries or interfaces in the actual system itself? Essentially, we're applying the scientific method to a running web application. In order to apply the scientific method properly, we'll need a good overview of our architecture. For this talk, let's imagine we have this set up here. There's a really good chance all of our stacks are different, so I'll try to be as technology agnostic as possible. So on the left, we have our clients, which are web browsers. As a request goes through our app, it'll go through our CDN, and then our load balancer with our application servers next, that is our backend, and finally, our application servers get data from a database. From the architecture diagram, we can see the boundaries between the systems. At each boundary, we have input and output. Later on, we'll take a look at some tactics for exploring these boundaries or interfaces. I'm also going to assume that you have access to your application's codebase and can run it locally. This enables us to debug our local application in parallel to production. We can compare our local input and output to what we glean from the production application. This also raises a question. What could actually be different between these environments, between production and local? An easy first step is to ask ourselves, is there a configuration difference between our local application and production? These configuration differences are often the cause of unreproducible bugs. I would recommend becoming familiar with your stack's build process. For example, the flags passed in module bundlers like Webpack. This is a place where these bugs tend to pop up first. All that was great, but what if we're not familiar with this particular system or code base? We might be a new hire, it could be our first time on call. What should we do? Very silly, but phone a friend. So ask a colleague that's a subject matter expert or on that system or code base to pair with you. Don't be afraid to bother them. It will save your team lots of developer hours and give you a chance to learn from pairing on a hard problem. All right, so let's start at the beginning. We're going to start our debugging journey all the way at the beginning with the CDN. So the CDN is the first step in our request journey. CDNs are content delivery networks. Most companies don't run their own CDN. They use a provider like Cloudflare or Akamai. There's a bunch of other ones. If we use a CDN, our end users will have requests fulfilled by edge servers that are geographically closer to them, which means they'll likely see performance gains. But if we're trying to reproduce a bug, there might not be a guarantee that we ourselves will hit the same edge server as an end user. CDNs are also used to cache assets like CSS, JavaScript files, image files. You can do full page caching or partial caching and much more in CDNs. And honestly, that all sounds pretty great, right? Unfortunately, CDNs can also cause hard to reproduce bugs in production. Depending on how complex your setup is, you might run into stale assets, which means your end users could get served old JavaScript files with breaking changes. That's not great. And there could also be issues with the redirect rules, firewalls, and much more. There's a lot you can do with modern CDNs. So while we should definitely use CDNs in production, we need a strategy for ruling them out as the source of a bug. So one weird trick to rule out CDN issues is to bypass the CDN entirely and hit your origin server directly. Going back to our architecture diagram, this is what it might look like. So instead of our clients going through our CDN, they would hit the load balancer or our origin servers. So as a quick caveat, most companies tend to restrict making requests to the origin server to internal networks, so you need to watch out for that. But honestly, if your bug is gone when you hit your origin server directly, then your problem is probably solved. You probably want to investigate how your CDN configuration caused the issue, but it might be related to the deploy process of your application. CDNs allow for a form of caching. So let's focus on handling bugs caused by caching next. So please read this. I'm going to drink some water while you folks read that. As a quick disclaimer, Jeff Atwood was not the first person to coin this, just so you folks know, you're all in the know. But he got the most retweets and likes, so I chose that one. So we can have caching in a lot of places, right? We can have caching client-side in the browser. We can have caching server-side in our web applications. We can have in-memory caches. We can have caching at a database layer. There's a lot of places where caching can appear. So let's go through some of them. With client-side caching, we can have it via web storage. We can use cookies. You can have caching in service workers. So there's a lot of places for things to go wrong. We're going to start off with client-side caching and take a look at a quick example. So here's an example where we're going to fix an issue with client-side caching. Notice how that last to-do item, that looks a little bit wonky. There's actually nothing there, right? So let's take a look at what's going on. So last one is wonky. We're going to reload the page. Still wonky, so there's probably a caching issue somewhere. We're going to open up Chrome's developer tools. If we take a look, we have something in local storage, nothing in session storage, nothing with the cookies. So what we're going to do is we're going to clear out local storage. Once we clear it out, we're going to reload the page. Our to-do list application is back where it should be. We're going to buy some bread. Maybe we're millennials. We want to make some avocado toast. But we can see that the application itself still works. So once we cleared the cache, the issue disappeared. So that last example was a little bit simple, granted, right? But even for complex applications, I recommend ruling out client-side caching first by using an incognito window or a different browser. You can also flush the cache just like I did. I promise that it will save a lot of time. For server-side caching, it's hard to get insight into what was actually cached. You can check your application's logs, or you can check the cache directly if you have access to it. But honestly, the easiest solution is to flush the entire cache, just like what we did with the client-side example. Yes, I know that is a cop-out. It's the equivalent of turning something off and on again, but caching issues tend to be really hard to debug, especially if you have a distributed cache. So this is a very quick sanity check. If your bug still occurs after this point, it's probably not caused by server-side caching. Quick note, this is a fair warning. Please make sure you're very careful when clearing out any caches. Maybe don't do it on Black Friday, don't do it on a time where you're taking a lot of traffic. Don't take your applications down when you're trying to debug them. Just a fair warning. So we saw how caching in our applications can take a turn for the worst. Let's take a look next at client-side JavaScript running in the browser and see how to debug those issues. So this is the JavaScript that is running in our end users' web browsers. It could be a desktop browser, it could be a mobile application, or a mobile browser. And honestly, debugging client-side JavaScript is actually a lot of fun. We can interact with the code directly in the browser. There is one downside, though. It just tends to be minified. So if we take a look at this code right here, it's all minified, it's on a single line. It's very hard to see what's actually going on. So that makes things a little bit interesting. So let's go back to one of our previous questions. Can we do anything to get more introspection into the system? We can use source maps to debug any compressed JavaScript. You can generate one from the tool you're using to actually compress your original JavaScript files. After generating a source map, we can use Chrome's DevTools to apply it directly. So here, I'm going to add a source map with the URL. Once I add in the source map, the unminified JavaScript file is there. It's totally readable. It's exactly like how we'd interact with a JavaScript file in a text editor. So also note that you can typically generate these source maps such that the browser's DevTools will load them automatically without having to do the manual URL insert that we had to do. There's usually a configuration in the build tool for that. In case you can't generate a source map, and that definitely happens sometimes, there's a preprint option in Chrome. If you had anything that was mangled, there were any variable names and other identifiers that were changed, it's not going to help with that, but it does make the debugging experience much smoother. At this point, after we've unminified our code, it means that it's actually usable. So with client-side JavaScript, we can place arbitrary breakpoints using the browser's developer tools. These breakpoints give us input and output data that we need for debugging. To place breakpoints at the right place, what we're going to do is use our local application as a wayfinder when examining production files. We can map identifiers from our local files to identifiers in the minified code in order to determine where to actually place those breakpoints. So let's imagine that we're focused in on this edit function. We have to-do edit going, maybe it's broken for whatever reason in our application. Let's try to find an identifier in this piece of code. We can see that things like enter key and escape key, they'll probably be preserved after the minification. So let's focus in on that enter key property and see if we can use this piece of code right here as a wayfinder in our production code. So looking at this in action, we're going to go back to the browser, go to our very broken to-do application. We're going to search for that enter key identifier and see if we can find it. So we're going to search for it all through our files. Maybe we have multiple JavaScript files. So we're going to search for enter key. It's in that minified code. And then we're going to preprint it and try to find where it's actually used in this piece of code. This way we can tie what we saw locally with what we see in production. And what we can do next is actually put a breakpoint on that line to see if we hit it in our running application. If it was broken, this is one way where we could get to the point where we can actually see what's going on in this function. So I'm going to try to edit that to-do item. We stopped at that breakpoint, so we're able to figure out what production code was running based on the wayfinders in our local code. We're able to map it one-to-one. So after we've got our breakpoint in place, you might notice that the bug that we have is actually very tedious to reproduce or isolate. This can often happen with collections. When we have arrays of objects or arrays of arrays, we might have only one object that is faulty. Everything else might be great. So at that point, I would recommend using conditional breakpoints to only pause when the error condition for that bug is triggered. Honestly, like the worst thing to do is just sit around and like hitting that play button for hours trying to figure out which object caused that bug. It's even worse when you actually miss the scenario that caused the bug and then you have to do it all over again. It's not fun. So let's take a look at how to do this. So our app is broken. There's nothing there. Great. Let's see what's going on. We got this scary runtime error. It's all red. There's a bunch of lines. Let's figure out what's happening. Let's narrow down to the line where the error is occurring. Let's put a breakpoint on that line and see if we can figure out what's going on. So we stopped on that line, but for this value, for this object, things are good. It's all working. And we'll play it again, see if we can get to it. So at this point, we're going to add in a conditional breakpoint. We'll only stop when title object is falsy. This way we'll narrow down to the actual object that causes the issue. So you notice for this to-do item, the title object doesn't have a value. So for this one, it's undefined. Once we try to access that title property on title object, it'll error out. We're able to narrow down to the actual object in our collection that caused this issue by using a conditional breakpoint, instead of having to go through every single to-do item. Going even beyond that, we saw that the previous example was written using React, right? The props kind of gave it away. Something else that we could do for this input introspection is to use React's DevTools. With the React's DevTools, we can get insight into the props and state values without needing to set actual breakpoints. If we really think about it, these props and state values, these are the actual inputs to our components. So let's take a look at that in action. So our to-do app is also broken again. It's a very buggy application, but it turns out it's broken in a slightly different way. We can see that there are two components that look a little bit weird. We have those two to-do items. So we're going to use React's DevTools. We're going to focus in on, first, one of the good components. So buy bread, that looks great, everything's there. Let's take a look at one of the broken components next. So this one's great, it has everything it needs. Looking at this broken component, you can see that there's no state. It's actually missing some properties underneath that to-do prop as well. And if we take a look at the next one, same thing. So instead of having to set a breakpoint or go through that manual step, we're able to debug this without using anything like that. We were able to use React's DevTools to compare a good component to a bad one and see what the difference is. And focusing in on this idea of data and looking at the difference between something that works and something that doesn't work, we can start to use command line tools to help us out. This is really helpful for very large data structures. If you end up with very large prop and state values, what we can do is start to serialize that data and use command line tools to inspect it. This will help us investigate any data integrity issues. So in this example, we're going to focus in on the function where we have previous props. We're going to serialize previous props by using json.stringify, and then we can use the copy method that's built into Chrome's DevTools to actually copy it to our clipboard. We can do this for any of those objects, or really any of those values. So what we're going to do is grab previous props. We'll also grab our current props. So we'll save that serialized JSON from our clipboard into actual files. We're going to skip that step. So we have a previous props.json file, or props.json file, and we have this JSON diff npm package that we also installed. So let's take a look at what's happening. We can start to compare some things. If we take a look at this title property right here, we can see that the title changed, right, between our previous props and our props, and our completed property also changed as well. So this way we made our investigation easier by using actual command line tools that were built for these things. Instead of doing it directly in the browser or doing it by eye, we're able to leverage these command line tools to help us out. So we've been looking at the data in our to-do app and how it's been broken along the way. But that does raise a question. This data has to come from somewhere, right? So let's take a look at that data transfer process next. This actually raises the question, how do our applications get the data they need? In some cases, we make AJAX requests from the client. The requests are eventually handled by our application servers. So we end up with this boundary right here, where we transfer data from our application servers. Unfortunately, that means that we can have bugs when we actually create the request in the client. We can have bugs when these requests are handled server-side. And we can have bugs when we handle the responses client-side. So we have three main areas where issues can occur. So that means that our goal should be to get as close as possible to the actual requests, ignoring any of the underlying code or anything that's surrounding it. We should try to get as possible to the actual request in our application. So we are very lucky because we can actually inspect these AJAX requests directly in the browser. So here, what we're going to do is take a look at the AJAX requests that get made every single time we add a new to-do item. So I'm going to add in a new to-do item, very into owls. I'm going to buy an owl costume. I'm going to start to research some owl behavior. And we can see that as I dig into my owl research, we make subsequent AJAX requests for all of these. So instead of looking at the code itself, we can focus in on that behavior at that interface. We can see the data that was returned from that request and have it be parsed and all that good stuff. We can also see the data that we pass in as part of our request. And as we start to interact with the application and start marking items as completed, we can see the requests that get made for those as well. So quick note, there was an initiator column before as well. If we hover over that column, we can actually see what caused that request, along with the stack trace. So we can narrow down to the exact piece of code that caused the request. We can see the data that was passed in with the request. We can also see the response that was returned from the request as well. By inspecting the AJAX request in the network panel, we can figure out if we actually made the request successfully, if we provided the expected request body, and if we even received the expected response. These are three areas where things can fail. And it gets even better, because what we can do is start to replay that request without the browser, without dealing with any of that other application code, by using curl. We can use it to see how our backend handles just that request. We're going to isolate our system to just those requests. So what we're going to do is we're going to grab the curl command for each of these requests. Chrome's DevTools will help us out. We can right-click, copy as curl. So we just copied it. We're going to paste it in our terminal. And then we can see the output for just that request. What I just did is I piped it to JQ. It's a very common command line program for dealing with JSON. So we can see the actual return values for our AJAX requests and isolate it to just those endpoints. So we can do this for requests outside of AJAX requests. We just have to recreate the request ourselves. So it's very much doable. We just have to determine which headers to pass, or the request body and all that, but it's very much doable. So what gets better is once we have that curl command, we can start to edit it to test our system. We can test the various input and outputs. So editing curl by hand is a recipe for disaster. So I'm going to copy it, and I'm going to use a tool like Postman, where I can import curl, and I can interact with it directly as a first-class citizen in this application. So instead of buying a regular owl costume, I'm going to buy a cool owl costume. So I just sent that request. It hit the backend server. I can see that the to-do item was saved. And if I refresh, I should see that request, if it succeeded, appear. So now I have buy cool owl costume in my to-do application. So instead of dealing with the application itself, I was able to isolate it to just that backend server and just that endpoint by using curl and then editing the actual request that was made by using Postman. There are other similar tools like Postman, like Paw, and so on. This is great, because if we suspect that at some point there is a race condition in our code, what we can do is instead of trying to manually reproduce itself, instead of trying to spend hours trying to reproduce that race condition, what we can do is continuously repeat those curls. So if we take a look, here I have a bash script. We could do this in any programming language. I have the curls that I got from Chrome. We can also write this ourselves. We have 2 endpoints on production. So we have endpoint number 1 and endpoint number 2. If we suspect that there's a race condition when these 2 endpoints are hit consecutively, what we can do is make these requests. We can do it 100 times. The bash script will help us out. So whenever we suspect that we have a race condition in our code, maybe it might be that we think some code is synchronous, but it might actually not be. There might be issues with database transactions. We can reproduce those race conditions by using curl and by using a simple bash script. We can also rewrite it in an actual language like Ruby or JavaScript, but a bash script works as well. So this is a great way to reproduce race conditions. So instead of having to try to do it ourselves, we can let the code do the work for us. And this is especially helpful when you have database transactions that might not be guaranteed. Sweet. So we covered a lot. We're going to talk about server-side debugging next. So we're going to investigate the actual code running on our servers. So fair warning, this is a place where getting introspection is a bit more difficult. And quick caveat, if you have tracing, log management, and other tools, just please use them. There's Splunk, Datadog, New Relic. There's a bunch of other fun vendors that do all of this. You don't have to do it yourselves. And all the following advice still applies if you have these tools. It's just easier to apply the advice. So here are our production application servers. We're going to imagine there's 3 of them. Why not? These are the servers that are handling requests from actual users. So we probably shouldn't edit the code on these servers directly. We probably shouldn't put a breakpoint or do anything like that. So what we can try to do is match the entries in our log files to the actual logging code in our application. This way we can treat the log files as a wayfinder to the code that's been executed. So one thing that we can try to do is also use the curls that we saw before and actually isolate the specific endpoints that we care about. We might have to write these curl commands ourselves, but it's a lot like the Ajax technique we saw before. What really helps is that if you're taking production traffic at that time, you might see a lot of messages in your log files. I highly recommend finding a GUID or some other identifier to find the entries that are relevant to you. You don't want to deal with actual customer entries. You want to take a look at the entries that are you yourself testing your code. So it's going to be a wild goose chase if there are a lot of other entries from actual users. So here in this example, what we're going to try to do is find a GUID, and we're going to use the ID of our to-do item as a GUID. So going back to the browser, I'm going to right-click, inspect, try to find an ID that I can use to search the application logs. So luckily for us, our to-do items have this data-id attribute. We're going to grab that ID. Let's hope that's unique. Let's make a change in the application. We just deleted a to-do item, and we're going to search for that ID. So here I used iTerms find feature, but in real life, we probably use a tool like grep to help us out. This is for simplicity, but in real life, we probably pipe this to grep and find the entries that were relevant for us. So this ID right here matches the ID of the to-do item that I just deleted. So if there was a lot of other log messages, I can narrow down to the one that I myself care about. So what if there is no GUID? So depending on how your application handles optional query params, you can actually create your own identifiers. So I'm going to create a new to-do item using Postman. And I'm not going to see anything in the logs by default. I'm going to write adding a to-do. I see that log message. I don't know if that's me or somebody else. Who knows? So what I'm going to do is I'm going to add in a GUID myself. I'm going to just do something silly, foo equals bar. And if that shows up in the logs, I know that this was me making the request as opposed to an actual user. Here, I'm able to identify the request that I made versus the actual traffic that is hitting the application. All right, so we're almost at the end. And these next 2 tricks are very sketchy. So I really recommend asking for permission before doing these. I'm pretty sure they're going to get very dicey with compliance, or if you have PCI compliance or HIPAA, probably don't do these, but just ask for permission first. So the first trick is we can use TCP dump, a command line packet analyzer, to actually inspect network traffic on our production servers. So you'll be able to see the actual requests that are made and view the request bodies. This is extremely helpful because we can see the actual request data before it hits our application on the production servers. So we can try to pinpoint the issue to the HTTP request itself. We can see the data in the request, and if it's not the request, if it's not the data, that's probably the application code itself. So here's an example of what it might look like. The command is tcp dump. We're going to inspect the traffic on port 777. Depending on how many services you're running at a time, it might be a different port. We're going to pipe it to grep to narrow it down to HTTP traffic. That -c flag is for 20 lines before and after. And there are other command line tools you can use. You can get very fancy with this. If you want to get even fancier than this, what you can do is actually export that packet dump from your production services and use a tool like Wireshark for easier analysis. It's a little bit easier than dealing with grep. So let's take a look at what this might look like. So I'm going to run tcp dump. I'm going to pipe it to grep. I'm going to focus in on localhost 8080. Just do 10 lines before and after. So I have my application running. I can see some messages here from tcp dump. So what we can do is go even further and see how, by using Postman, what happens in our application. So I had a super secret endpoint with a super secret key with a super secret value. I made that request using Postman, and I can see the request come through and see that it's actually handled by the application. This request did fail, so now I can figure out why that request failed. All right, this next trick is also very sketchy, so I don't really recommend doing it, but if you need to, you can. So what we can do is remove one of our application servers from the load balancer and just deploy code to it directly without breakpoints. We had 3 application servers before. We're going to remove that very bottom one down there. So we can see that it's going to bypass. So any customers will never hit it, right? The idea is that no customer will get a bad experience, but we can set breakpoints on the code running on that application server and figure out what's going on. We've isolated it for the rest of our system. If there is a configuration bug, we can narrow down that configuration bug just on that server itself and treat it like how we treat any other code that's running. But the good news is no customer will get a bad experience. All right, so we're almost there. The last, and honestly, this is the best tactic. If you take anything away from this talk, just remember this tactic right here. So the last and final tactic is to just give up. And there's always an and, right? Is to add logging in key code paths. So after we add that logging, we can deploy our code as usual. Treat it as business as usual. Just deploy the code. It goes out whenever it goes out. And this is great because in the future, we can use those log messages to reproduce the bug. If it takes 1,000 requests to see the bug, we can let the code run wild. When it happens, we will see it in our log messages. So we can do this server side for client-side logging. There's a bunch of vendors like Sentry or Bugsnap that will let you capture the message. And you can go even further. If you're so inclined, if you really care about this bug, you can page yourself when this bug happens. I wouldn't necessarily recommend it, but if you're super invested, it's good to know as soon as possible when this bug occurs so you can try to reproduce it in the exact same conditions. All right, so let's start to wrap up. We went through a few underhanded tactics for debugging in production. They revolved around our ability to investigate our applications without editing any code. We needed to apply the scientific method to our running applications to see what was happening. What code was actually executed? How do we narrow down to the input and output data? What actually is happening on the applications themselves? So I really hope they're helpful when dealing with your next production bug. That's all, folks. Thank you so much. If you have any questions, I'm happy to answer them and all that good stuff.